Have you ever gazed up at the stars and wondered if we're alone in the universe? This question, this sense of cosmic curiosity, has been at the heart of humankind's quest for knowledge since time immemorial. Enter Enrico Fermi, a brilliant physicist who pondered this very question and proposed a paradox that's puzzled scientists to this day. Simply put, Fermi's paradox looks at the contradiction between the high probability of extraterrestrial life and the deafening silence from the cosmos. Here's the thing. Our galaxy alone houses billions of stars, many of which are likely to have planets that could potentially support life. Given the sheer scale of the universe, the odds should be in favor of intelligent life forms existing elsewhere. Yet despite our advanced technology and relentless search, we have yet to make contact with any alien civilizations. So, why haven't we heard from any aliens yet? To begin to answer that question, we first need to understand the Drake equation. This equation, conceived by Frank Drake in 1961, is an attempt to estimate the number of civilizations in our galaxy that we might potentially communicate with. Let's break it down. First, we start with the rate of star formation in our galaxy. Then we consider the fraction of those stars that have planetary systems. Next, we include the number of planets that could potentially support life as we know it. After that, we factor in the fraction of those planets where life actually develops. We then consider the proportion of life that evolves into intelligent beings, followed by the fraction of civilizations that develop technology that releases detectable signs of their existence into space. Lastly, we consider the length of time such civilizations can broadcast their signals. But remember, even with the Drake equation, we're dealing with a lot of unknowns. What if the silence isn't due to a lack of civilizations but due to some insurmountable barriers? This is a question that has perplexed scientists and thinkers alike. The cosmos is a vast uncharted territory teeming with physical and biological hurdles that could prevent civilizations from reaching a point of advanced development. For instance, the harsh conditions of space, such as extreme temperatures, radiation, and the scarcity of resources, could stifle the progress of a civilization. Similarly, the evolution of life itself is a complex and intricate process that requires precise conditions. Any slight deviation could halt the progression of life from simple organisms to intelligent beings. However, there's another, more ominous theory that might explain the silence we're experiencing. It's called the Great Filter Theory, proposed by economist Robin Hanson in the mid-90s. The theory suggests that there's a significant barrier or a series of barriers in the path of evolution that are extremely difficult to cross. This filter could be anything from a catastrophic event like a supernova explosion to a self-inflicted disaster such as a nuclear war or an environmental catastrophe. The Great Filter Theory posits that most civilizations are wiped out when they encounter this barrier, explaining why we haven't heard from them. But here's the chilling part. If the Great Filter does exist, it raises a critical question about our own existence. Have we as humans already passed the Great Filter, or is it still lying ahead of us? If it's the former, we might be among the lucky few who have managed to navigate the treacherous path of evolution. On the other hand, if the Great Filter is still in our future, it implies a rather grim fate. It means that our civilization, like many before us, could be on the brink of a cataclysmic event that would halt our progress, or even lead to our extinction. So, as we gaze into the cosmic abyss, we must ponder this unsettling thought. Could it be that we've already passed the Great Filter, or is it still looming in our future? Despite the silence, our search for extraterrestrial life continues. But how exactly do we go about finding life in the vast expanse of the cosmos? It's a needle in a haystack situation, but we've developed some pretty sophisticated tools and methods to aid our search. One of the most well-known initiatives is SETI, the search for extraterrestrial intelligence. SETI scientists use radio and optical telescopes to scan the sky for signals that might be artificial in origin, potentially broadcasted by a distant civilization. It's a bit like tuning a radio, but instead of hunting for your favorite station, we're hunting for signs of intelligent life. In addition to looking for signals, we're also on the hunt for habitable exoplanets. These are planets outside our solar system that might have conditions suitable for life as we know it. Thanks to space telescopes like Kepler and TESS, we've discovered thousands of exoplanets, some of which reside in what we call the habitable zone. The habitable zone, also known as the Goldilocks zone, is the area around a star where conditions might be just right. Not too hot, not too cold, for liquid water to exist on the surface of a planet. Since water is essential to life as we know it, finding a planet in the habitable zone of its star is incredibly exciting. But the truth is, we're still learning. Our understanding of what constitutes a habitable zone is evolving, and we're coming to realize that life might be possible in a wider range of conditions than we previously thought. Life, it seems, is incredibly tenacious and adaptable. In the end, our search for extraterrestrial life is about more than just finding aliens. It's about understanding our place in the universe, about pushing the boundaries of our knowledge and our capabilities. It's a journey of discovery that's just as much about us as it is about the stars. As our technology improves, so does our ability to search for signs of life beyond Earth. But what happens if we do find evidence of alien life, or even more intriguing, what if we are the evidence? This brings us to the fascinating realm of contact theories and the simulation hypothesis. Contact theories explore the possible scenarios that might unfold upon establishing contact with extraterrestrial civilizations. Some theories suggest a peaceful exchange of knowledge and technology, while others caution against a potentially dangerous encounter with beings far more advanced than us. One particularly engaging theory is the zoo hypothesis, which suggests that we might be intentionally left alone, like animals in a zoo, observed from afar by alien civilizations. Or perhaps we're dealing with the prime directive hypothesis, inspired by Star Trek's non-interference principle, implying advanced civilizations might deliberately avoid contact with less developed ones to prevent cultural contamination or technological exploitation. Then we have the dark forest theory, painting a more ominous picture. This theory likens the universe to a dark forest where civilizations remain silent to avoid attracting predators, hence the apparent silence of the cosmos. Now let's take a leap into the realm of the highly speculative yet intriguing simulation theory. This theory proposes that our reality might not be as real as we think. Instead, we could be living in a sophisticated simulation, a hyper-realistic virtual reality created by a more advanced civilization. Imagine this: if a civilization reaches a certain level of technological advancement, they might be capable of creating a simulation indistinguishable from reality. Sound far-fetched? Perhaps, but consider how far our own virtual reality technology has come in just a few decades. Project that progress into the distant future, and the idea doesn't seem quite so outlandish. In this scenario, we ourselves could be evidence of extraterrestrial life. We might not be biological beings exploring the universe, but digital entities within a cosmic computer game, our actions and decisions influenced or predetermined by our unseen programmers. Could we be living in a simulation created by a more advanced civilization? As we delve further into the cosmos, we might just find ourselves facing this extraordinary question. So, if the universe should be teeming with life, why is it so quiet? It's a question that has perplexed scientists for decades and forms the crux of the Fermi Paradox. But there are potential resolutions to this conundrum. One explanation suggests that we may simply be looking in the wrong places, or perhaps more accurately, looking for the wrong things. We're carbon-based life forms, and as such we naturally look for signs of life as we understand it. But what if life elsewhere in the universe doesn't play by our rules? What if it's not carbon-based at all? Some scientists propose that silicon, due to its similar properties to carbon, could serve as the building block for life on other planets. This, of course, would completely change our understanding of what to look for when we're scanning the cosmos for signs of life. Another resolution to the Fermi Paradox revolves around the search for alien megastructures. These are hypothetical large-scale artifacts created by advanced extraterrestrial civilizations. The most well-known of these is the Dyson sphere, a structure that could theoretically envelop a star and harness its energy. If such structures exist, they could be evidence of civilizations far more advanced than our own. But so far, our search for these megastructures has come up empty. And then there's the possibility that we're simply not listening properly. Our methods for detecting extraterrestrial communications might be inadequate. We're tuned into certain frequencies. But what if extraterrestrial civilizations are broadcasting on a completely different band? Or what if they use a mode of communication that is beyond our current understanding? In the end, the Fermi Paradox reminds us of our limitations and ignites our curiosity. It underscores the vastness of the universe and our small place within it. It makes us question, explore, and strive for answers. Perhaps we just need to keep listening, keep exploring, and most importantly, keep questioning.